In this episode, Sasha and Keoni looked for patterns in the equations that they have developed in this lesson. This allows them to predict the equation for a base parabola that has been moved in two directions, to the right 7 units and up 2 units. Then they determine the equation for this new parabola, which has a vertex of 7, 2 and a p-value of 3.
Now we're going to move that base parabola to the right 7 units and up 2 units, so its vertex will be 7, 2. What do you predict the equation will be?
Y equals x minus 7 squared over 12 plus 2.
Go ahead and write that down.
Is that what you were
That's what I think too.
Okay.
And that's positive, right? So minus 7 squared over 12 plus 2.
So you each had the same prediction?
Yeah.
What's your thinking behind it?
We just
Combining what happened with those two.
Oh, okay. You took part from the first one and part from the second one? Well, let's see if you're right. So go ahead and derive the equation for this parabola.
Let's check the special point. Here's the special point. I just know it's the special point. 1, 2, 3. Focus.
I'm gonna write in the
2, 3. Oh wait.
What are you counting?
1, 2, 3.
What are you doing?
1, 2, 6. 6. Okay.
You want the
it's
line?
right. It's right.
Okay, you're
it's
good.
right. It's right.
Just right into directions.
All right. So
Can
there's.
you explain what you were thinking there?
Okay. So I found our special point, and then I found our focus. And the amount of units away that our focus and our special point was the amount of units I used to find our directrix.
Talk me through that. So how many units was the special point from the focus?
6.
So then you counted down 6 units and
Yes.
found the directrix.
At -1.
So could you draw in that line and label it?
Yes.
And what is the equation for that line?
Why?
Y equals -1.
And could you also label the focus?
Focus. What's that? 7 and 5.
Okay, go ahead and...
Now we don't have to use this point.
And Sasha, do you agree with his placement of the focus and the directrix?
I do indeed, because our P is 3, so then our focus is going to be 3 up from the vertex, and then our directrix is going to be 3 down.
Great.
Can you use this one?
Go for it.
You can do the ones this time.
It's like that, right?
Mm.
That's good enough, right?
Mm-hmm. Okay.
Did I forget any lines?
No.
Okay, right?
And what's the coordinate pair for your other point there?
X and Y. So we have our x minus 7. And then we have our y minus 1. And our y minus 1 is right there too. And we have our y minus 5.
Y plus 1.
Y plus 1?
'Cause it's
Oh,
a-
plus 1. You're right.
Let's talk through each of these.
Oh, wait.
So you started out with y minus 1 and changed it to y plus 1. How come?
Well, it's because I saw the -1 down here, so I was thinking, oh,
Ah.
y minus 1. But yeah, you're right, because we're adding a unit right here.
So where's the distance y?
Our distance y is from our point to our origin.
Okay,
Or
and then the
our
1.
x-axis. Our 1 unit is right here. And, yeah.
So the distance y plus 1 is the distance between what and what?
Our point and our directrix.
And you needed that because that helps you do what?
Helps us find the equation.
Okay, so I
Yes,
saw
there
you
you go.
put y
Yeah.
plus 1 in another spot.
Yeah, right here.
Oh, because, equal
Yeah, because
distance from
equal
the
distance,
focus,
yeah.
so we could do Pythagorean theorem.
And how about the x minus 7? Sasha, did you agree with that?
Yeah, because this entire part is our x value, so then you have to get rid of the 7 units that it goes over to
And you're
our
left with
focus.
the
And yeah.
x minus 7.
Yeah.
And how about the y minus 5?
Do you agree with me there?
I do indeed.
Okay.
Can someone explain it to me?
Because our y is 7, and we're subtracting 5 units to add this little chunk of our
And why do you
triangle left.
subtract the 5?
Because it's 5 right here. 1, 2, 3, 4, 5 up from our origin.
our
Okay.
focus.
And that 5 sort of breaks down into a 3 and a 2.
Yeah.
Yeah.
The 2 was for what?
Our
The 2 is the distance from what to what?
The vertex and the wait, is
Origin.
it 3? No, okay, that's the 2, and then the 3 is up to the focus.
So that's the p-value.
Yeah.
Yeah.
Okay, great.
Sasha and Keoni started by identifying a right triangle. To find the lengths of the sides of the triangle, they first found the distance from their general point, x, y, to the directrix. The distance from the general point to the x-axis is y units, and the distance from the x-axis to the directrix is 1 unit. Together, the distance is y plus 1 units. The distance from the point x, y to the focus is also y plus 1 units because of the definition of a parabola. The length of the vertical side of the right triangle is y minus 5. That's because the distance all the way to the x-axis is y units. Then, Sasha and Keoni subtracted the distance between the x-axis and the vertex, which is 2 units, as well as the distance between the vertex and the focus, which is 3 more units, for a total of 5 units. This leaves the distance y minus 5. Finally, the length of the horizontal side of the right triangle is x minus 7 units. That's because the distance from the general point all the way to the y-axis is x units. Then Sasha and Keoni subtracted 7 units so that the length of the horizontal side of the right triangle is x minus 7. Next, they apply the Pythagorean theorem to derive the equation for the parabola.
So we have y minus 5 squared plus x minus 7 squared equals y plus 1 squared. Y squared minus 10y plus 25. Oh, we're going to leave it like that, right?
Yep.
X minus 7 squared is y squared plus 2y plus 1.
Want me to do it?
Yeah.
Okay. Minus y squared, and then plus 10y, plus 10y. Should I do again like minus 1 over here, or should I just do 25?
2.
Minus 1, and then minus 1, and we're going to keep that over there. So we're going to have x minus 7 squared plus 24 equals, all that cancels. 12y.
And then divide by 12.
We're so freaking smart. Wait, plus 2.
2. Just
Right?
box it.
Sasha and Keoni successfully found the equation. It is y equals the quantity x minus 7 squared divided by 12 plus 2. Next, in the last episode in this lesson, Sasha and Keoni look for patterns by comparing all the equations that they have developed in this lesson.